everyone, welcome back to my channel and let's start our halogen series. In this video we are going to learn about the chemical properties, basically the reactions, how do the halogens react. We have discussed the physical one and the general chemical properties in the previous videos. You can watch those, but here we are going to discuss the chemical reactions mainly. So here we are going to learn how halides ion act as a reducing agent. Previously we discussed as an oxidizing agent while they donate electron. Describe and explain the reaction of halide ions with aqueous silver ion. This is an important test. So we are going to learn this test, how to identify the halogens, and then we are going to learn how the concentrated sulfuric, how they react with concentrated sulfuric acid. So let's learn about the reducing agent. How do you define the reducing agent? It actually reduce others, not itself. It reduce others, but oxidize itself, means it donate electrons to others and becomes a positive charge. So how do this happen? So it's quite common because if the size is bigger, it's easy to lose the electrons, so they can become a positive ion as well. And we will learn later in this video how they become the positive one when you look at their oxidation state. So a reducing agent, they donate electrons to other, mean they reduce others, and the reducing power of halogens increases down the group. The reasons are quite obvious. Number one, the bigger size of an atom, the shielding effect. That's why they are like quite easy to lose electron. So outermost electron get further away from the nucleus. Why? Because of the atomic radii. The bigger size allow or makes it more easy to lose electron, and the shielding effect, the shielding effect of the inner electrons, that actually weakens the force of attraction between the nucleus and the valence electrons. So let's go in the details of the how we test halide ions. If a certain compound is given and you are asked how to just identify what type of halide is present in it, just carry this a simple test. First of all, you take a sample in a test tube using a dropper or a pipette, and then add few drops of nitric acid. After this one, you have to add the few drops of silver nitrate solution, and you will observe the change in color or change in state. So when we talk about the chlorine one, there would be appearance of almost white precipitates or the white appearance. In case of bromine, you will observe a pale yellow appearance or cream color compound is formed, while in case of iodine, a dark yellow compound is formed. So this is how you identify it. But sometimes it feels that maybe A and B are quite similar. If you perform the test, you can easily observe. You might feel that these are similar. Now how to differentiate it? Because you it it's not that easy to differentiate between these two colors, though these are looking really different over here, but when you perform it actually in the lab, they might seem similar. So what you do now, do then, you have to add ammonia solution to it to further confirm their identity. So the additional test is to add the ammonia solution. So there are clear indications, there would be results that tell you, okay, this one is chloride, halide, or whatever. So first of all, you have to put in the first one, the chloride one. If the precipitates dissolve, it means it's a chloride. If it doesn't, it means it is bromine. Simple. A bromide ion is present. Simple, simple. If it dissolves, it's chloride. If doesn't, then bromide. If they are looking similar, because iodine is quite dark in color as compared to these two seems to be quite similar. Then you have to add more you can say ammonia or a concentrated ammonia. So what will happen if now the precipitate dissolve? It means it's bromine. First of all, they are not absorbing dissolving in dilute one. Then you add more or add the concentrated ammonia. So if the precipitate dissolve upon adding more amount or the more concentrated one, then it means it's bromine. But if still they are not dissolved, they still remain as it, So it means it's iodide. Simple. So the additional test is you can just add in the ammonia. Let's have a summary of this test. First of all, we add a salt or whatever compound is given, we generally call it salt. Then we add nitric acid, then we add silver nitrate. Simple. These type of colors might be seen. So for additional tests, you have to add the dilute ammonia. If it dissolves, it means it's chlorine. If it's insoluble, then these two might be present. Then you have to perform one more test, add the concentrated ammonia. If the second one dissolves, it means it's bromine or bromide. If it doesn't, then it's iodide. Simple. So in this way, you can just identify what type of halide is. Clear? Now, what sort of reaction happens or take place in the presence of sulfuric acid? Now, with sulfuric acid, it produces toxic gases. So these reactions should not be performed without fume cupboards because they can they can have harmful effect on the health. So what will happen when they react with any halide? For example, if you say chloride or bromide, anything, hydrogen halide is formed. For example, we say hydrogen chloride gas is formed. You know it's toxic one. So it should performed in the fume cupboard. The hydrogen chloride produces wet. So what is the next step? Because it is aqueous, this is aqueous, so it would be wet. The next step is we just add more concentrated sulfuric acid. So concentrated sulfuric acid is a dehydrating agent as well. It dehydrates the other compounds. We use it to dehydrate most of the hydrated salts in the lab because it removes water from there. So a simple reaction take place. This is the operators or the setup that we use in lab. We have a salt over here, and from above we are adding the concentrated sulfuric acid. The reaction take place. The gas produced is collected in this delivery tube and passed on to the next one. Here the HCl gas produced is the aqueous one, or you can say the wet one, which needs to be dried. So here we are adding the concentrated sulfuric acid, which actually dries it up, and that dried HCl gas is collected in a gas jar. Simple reaction take place. So what happened with the bromine or the iodine? Now, keep in mind, as the size increases, it becomes easy to lose electron. So here it can easily lose electron in case of bromine and iodine. Let's just go into it. First of all, when a certain salt is added, it produces the hydrogen bromide and sodium hydrogen sulfate. Simple. So the color would be brown. But when we add in more one, the concentrated sulfuric acid oxidizes HBr. It means the reaction won't stop here. It will move one step further. And what is that step? The sulfuric acid, oxidizes HBr into bromine and water. Mean when the bromine is separated, the color will be reddish. Now HBr reacts with H2SO4 producing single bromine. Here sulfur dioxide is produced along with water. Simple reaction takes place due to presence of bromine. It appears reddish brown. Now second one is the iodide one. It would have more than two reactions, of course. The first one is the similar one. Sulfuric acid react with sodium iodide. It produces hydrogen iodide along with sodium hydrogen sulfate. The next reaction would be that it oxidizes hydrogen iodide to several extent. The concentrated sulfuric acid oxidizes hydrogen iodide and produce sulfur dioxide as happened over here. There is one more step more. So what is that step? The concentrated sulfuric acid oxidizes and it itself reduced to sulfur. Instead of SO2, sulfur is produced, and you can smell sulfur as well. It is also seen as a yellow solid. So If the concentrated sulfuric acid oxidizes and produce hydrogen sulfide, it can also happen. There is one more step. So hydrogen sulfide has a very pungent smell, a very poisonous, not poisonous, the smell of like the rotten eggs. So you can clearly you identify that hydrogen sulfide is produced at this point. So in general, when we just write about the reactions, keep in mind the reaction with chlorine is simple one. The size is smaller. It's not that much easy to lose electrons. But when we move to bromine or iodine, the reactions would be more. And in case of bromine, a reddish brown solid gas is produced. While in case of iodine, first of all, in the first reaction, the violet purple vapors are seen. In the second one, you can see the yellow solid, and in the third one, you can smell the hydrogen sulfide. Simple. So this is all for this video. Stay tuned and stay connected for more reactions related to chlorine.